Hi all, welcome to our YouTube channel. I hope everyone is doing good. Today we are going to see another classic Leetcode example for data structures and algorithm, that is threesome. It is very popular problem that has been asked in many FAANG companies as well and many other startups as well. So before solving this problem, I'm giving you a very clear disclaimer. Don't even try to solve this problem if you have not even attempted or if you have not even seen the twosome problems. There are two types of twosome problems, twosome 1 and twosome 2 in the same Leetcode. I would strongly suggest you to have a look into it, see the approach and understand the pattern that has been used to solve that problem, because that will play a major role in solving this problem as well. In case if you are not aware of this problem, I've already created a video on that and I've already solved that problem using Python in Leetcode itself. I can share the link of the video, the YouTube link of the video in the description below. Please check it out and then come back and you can refer this video for your reference. So getting started. So first we'll have a look at the questions. So first is we are given with an integer array, then that we're given an array of numbers and we have to return a triplet. Basically 3 numbers out of that array we need to travel, but the condition here is the position of I and j and k should not be equal. So if the position I is pointing at let's say 0th position, j and k or j cannot point in the same position. I should be in a different position, j should be in a different position, k should be in a different position. And while adding all these numbers, it should sum up to 0. If it sums up to 0, all these values should be returned, and these triplets should be returned, and these should not be repetitive. Notice that the solution does not set must not contain a duplicate triplets. For example, let's say a classic example. Let's see here. It's -1, 0, 1, 2, -1, and -4. If you see one of the set which adds up to 0 is -1, -1, and 2. But let's say there is one more set where the order is -1, 2, and -1. Even though they sum up to 0, there is already a duplicate of that array that is already present in the form of -1, -1, -2. So the duplicate should not be present. And but it is also important to notice that the array here is not sorted. Even if the interviewer directly gives you this question and he asks you to solve it, it is important you can have that as a question, or you can analyze whether first the array is sorted or not. If you've already been through my video of twosome, you will understand that the sorting of an array plays a major role in solving these kind of problems, especially for 2 pointers. And it is also important to notice that the numbers are repetitive. In the first example itself, if you see, you have -1 here and you have -1 here as well. So it's not like a number will occur only once, it will be repetitive as well. So these are the multiple examples they have given, and the constraint that they're given is 3. The length will be between 3 to 3000, and the numbers, this is just basic examples, basic constraint that they have given. So now let's go to a whiteboard, and first we'll try to address what we are trying to solve here. So all set. So problem that we are trying to solve here is threesome problem. So as we went through the problem, what are all the analysis? One, array is not sorted. Second one is repetitive numbers. Third one is no duplicate in output. Again, pardon me for my handwriting, but I hope you understand what I'm trying to tell you. So these are the conditions we could say we should have in mind while we are trying to solve this problem. Now the emphasis why I've been emphasizing on going through the twosome problem is that here this problem we are going to solve again using the 2-pointer problem. If I've already been through the previous video of twosome, you will understand how 2-pointer works. Anyway, I can give a quick overview here. So 2-pointer, basically we use 2 pointers. One will point at the one of the element of the array, the one will point at the extreme right of the array or wherever it is. And using this 2-pointer, we'll try to solve a problem. That is a classic 2-pointer problem. But if you see here 3 numbers are involved, because we are going to add 3 sums, and when you add these 3, it should sum up to 0. So that is a case that we are trying to solve. In such case, First, let's take an example and let's try to analyze how it works. So let's go to the problem description again. Let's say -1, 0, 1, 2, -1 and -4. So let's say -1, 0, what was that? -1, 0, 1, 2, -1, -4. 1, 2, -4. So again, if you have gone through to some problem, you will understand the importance of sorting the array, and here the array is not sorted. So here again, like I said earlier, or like I said in my previous video, I'm not beat around the bush trying to explain the brute approach and all this. I'll give you an optimal approach. That could be, this is not, I could not say this is the most optimal approach. There are two ways to solve this problem. One is using two pointer, and the other one would be using hash map. Here I'm giving you the most optimal approach for two pattern solving technique. So first step would be to sort an array, sort the array. That would be the very first step that we would be trying to take. So let's say we sort it. So when we sort it, what would be the least number? The -1 followed by -1, sorry, -4 followed by -1 followed by another -1, since we have -1 here, -1 here, followed by 0 followed by 1 and 2. So we have sorted it. After sorting it, what we need to figure out is we need to fix three numbers on addition of which it should sum up to 0. That is a target here. So what we can do, second step is, let's take the sorted array 0, 1, 2. So let's say we point it here. Let's -4 be the constant now. So it is going to be constant. So we are gonna fix the second number and third number upon which we add it will sum up to 0. So one number is going to be -1. Let's start like that. We'll go through a for loop while we declare this first integer, and we have to figure out two more numbers. If there exists two more numbers which can be added with -4 and that can sum up to 0. That's what we are going to figure out. So here, where two pointer comes into picture is that leave this one pointer aside. This one pointer is going to be constant for until it iterates through fully. Once this is going to be constant, we're going to declare two more pointers. One pointer will point at very adjacent to I, which is this I'm assuming it as I, very adjacent to I, and another pointer that will be in the pointing at the maximum value or the highest value or the extreme right value of a sorted array. The extreme value or the maximum value of an array when it is sorted will always have the highest value on the right. So we will have another pointer pointing it out here. So now this becomes a classic two-sum problem. So we have one pointer pointing on the lowest end and we have the other pointer pointing at the highest end. So the target will be, we have the constant number, we'll have the second number, and we'll have the third number pointing at the highest. We add them. So let's take this step. So -4 plus -1 plus 2. What is the value? -4 plus -1 -5 plus 2 is -3. -3 is equal to 0. Is it equal to 0? No. So it is not equal to 0. So now the control strategy would be, since it is not equal to 0, now if we already solved the two-sum problem, when the value is not met, when the target is not met and the resultant of the sum value is higher than the target value or lesser than the target value, we reduce the rightmost pointer by 1. Basically what we are trying to say is, when you add the numbers, it is leading to a number that is very less than actually what the target should be. In such case, we need to, it's not the right pointer, we move the left pointer by 1 position, because we need to get it close to 0. So again, what we will do, -4 will again constant, then we'll take -1 again, plus 2. Again, this, since it is repetitive, it's going to give the same number, -3. And is it equal to 0? No. So again, -3. -3 is less than 0. So again, what we are supposed to do, we are going to iterate increment j by one more value. Then j will be pointing to 0. So when it points to 0, what you will do, -4 plus 0 plus 2. Again, it results in -2. compared to -3, -2, it has come a little bit closer to 0. That's what we can see here. Since our array is already sorted and we step by step, we can be just assured that as we progress through, we might get some value that is close to 0 or greater than 0. So again, we increment, since it is lesser than 0, again we increment the value of j, and now it will point at 1. So what we will do, -4 plus 1 plus 2. Is it pointing to, is it a -4, 2, 3? Is -1. Again, is not equal to 0. And now you might be thinking, we will again, since it is negative, again we will increment j. But if you have gone through the problem description, it is very clear that the position of j and position of k should never be equal. So what we will do, we can understood that there is no probability of occurrence where -4 could be a part of a triplet. So what we will do, we'll completely discard this. Let me erase this. Okay. Let's completely discriminate this. Now let's have the pointer to be I to be at -1. So -1 is going to be constant now. And now the classic 2 pointer will start from here. J will be here, I plus 1, j will be here, and k is going to be pointed the highest element. So -1 plus of -1 plus 2, which is equal to 0. Is it beating? Yeah, it is beating. So it is equal to 0. So this is going to be a part of the triplet. So the values are going to be -1, -1 comma -1 comma 2. Then what we do, once the condition is met, we have to increment the value of j by 1 and decrement the value of k by 1. So why are we doing that? The reason why we are doing is that when the addition is already met 0, now our ultimate focus is not to find a value that is going to be greater than 0. Our value is it should be close to 0. Already when you add -1, -1, and the extreme highest value of the array 2, it is already pointing out to 0. So whatever number you add, even if you just increment j, let's say instead of -1 it points to 0, again it is gonna get a value that is not gonna be close to 0, because 2 is the highest value. So what we're gonna do, it doesn't make to have k just here, so we'll decrement k and increment j as well. In such case, what we'll have, -1 plus 0 plus 1. Are we getting the 0? Yes. Again, we are getting the 0. -1, 0, 1 is another set. Then what we are trying to do, so j will be here and k will be here. As I said earlier, j and k should never be in the same position. So we'll break the loop. Then we'll go over to 0. So this is the iterative process that we will go through until we get all the sets, and these sets needs to be written. But if you think this is the end of the problem, it's not actually the case, because if you have gone through the description very clearly, this is what is important, guys. When you go through the project problem, it can be even when you work in a industry, or it can be even when you work here, read the description and read the expectation clearly. Understand what is actually expected. Here it is important to notice that the solution set must not contain any duplicate triplets. So let's say we collect all these triplets, and there is some possibility by which I'm getting another, I'm just assuming another triplet in the form of -1 comma 1 comma, -1 comma 2 comma -1. This is already existing, and this is a duplicate. In such case, this will not satisfy the problem, or this will not be the right solution, right? So we need to figure out a solution where we return only the original unique elements, not the duplicates. For that, in this problem, we'll try to introduce a concept called something called a set. Set is an inbuilt data structure in Python. You can do a basic Google search. There are multiple blogs in W3 Schools, Geeks for Geeks as well. So it's a matter of 5 to 10 minutes where you can get a good idea about what actually set is. Let's search for set in Python. Pardon me for my internet, maybe it's a bit slow. But basically, I'll explain you. what a set is. So set is basically a collection of numbers. It's a basic mathematics. You would have got it. So in Python, it's nothing but a set of numbers. But the unique thing here is a set can never have a duplicate values. A set will have only the original numbers. Let's say I have a set of fruits. I have multiple elements in it. Let's say I have banana, I have cherry, I have berry. This is a set I have. Let's say I want to add one more fruit to my basket set. So what I am telling, I wanted to do one more banana into my set. But will the data structure of Python allow this? No. Python in data structure set will only have unique elements. And while these duplicate elements is very well possible in list, but never in set. So what we are going to do with set is then whatever output we have, first we'll store it in a set. The set will store only unique elements. So once our code goes through all the elements of the array using that for loop, and whatever is meeting the condition of addition of three numbers to 0, we'll store it in a set, and the set will make sure that duplicate elements doesn't exist. So we can, at the end of the day, we can return this set to meet the output. And again, if you think this is the end of the problem, no, we have one more condition here. If you can see the return, what it is getting returned is not a set but a list that has been very mentioned clearly. Nobody tells you, but you have to find it out here. If you just in Leetcode, at least if you just return directly the set, it might throw some error. So it's important to we store this set somewhere, and this set needs to be converted into a list. So set needs to be converted into a list, and this should be returned. This is how this problem is going to be solved. So what we can do now, I'll erase this and I'll create a proper pseudocode. We'll try to make a proper pseudocode so that the pattern we understand, and after that we'll start implementing this in proper Python code and Leetcode itself. Again, I'm giving you a disclaimer. Without knowing how a two-pointer works, like two-pointer problem pattern works, and without solving two-sum, I would not advise you to solve directly three-sum, because it won't be everybody's cup of tea for this. So practice yourself, try to understand that, check my previous video, see the pseudocode of that, see how I solved it. Even if you don't solve it, try to see how people have solved it. If not my video, anybody else's video, see how I have solved it, and come back here. That would make a lot of sense. That will make a fruitful learning for you as well. Okay. So, pseudocode. Pseudo code. Again, pardon me for misspelling if I made a mistake. First will be to sort the array. That will be the very first step. Then initiate for loop. Point one, we can say fix one element I. 2.2 will be fix second element to be I plus 1. 2.3 fix third, sorry for the guys, is not element, pointer, not element, pointer, and third pointer to be 2 max value. As you go through the for loop, you add that array. Let's say nums is array, nums of I plus nums of j plus nums of k. So here our target is to find three values that will sum up to 0. So what could be the possible probability, permutation or combination? One will be this sum will be equal to 0, or sum will be less than 0, or sum will be greater than 0. If sum is equal to 0, as I already said, increment second pointer, let's say 2, second pointer plus 1, and decrement third pointer by minus 1. And if the sum is less than 0, if the sum is if the sum is less than 0, which means that we need to increment j by 1 so that we take a step closer to 0 in that sorted array. So we will be incrementing just the second pointer by 1. When the sum is greater than 0, which means it's already too positive, which means we need to decrease the highest value, highest pointer. So which pointer is pointing to our highest pointer? The third pointer is one that is pointing at the highest value. So the third pointer will be put by -1. So if this condition is satisfied, fourth, if sum equal to 0, store in a set, then fifth would be convert set to list. Sixth one, return that list. So yeah, if I really hope you understood it very clearly. Though we have put it in a simple layman terms. Now, as a developer, we will go see it in the code how it is getting implemented. So it's time to switch to Leetcode. So yeah, let's start it. So we have already gone through the problem. So maybe we'll try to have this. Now we have the function. In the function we have nums is going to be an array. So first thing first would be to, as we discussed earlier, as we said in the pseudocode itself, the first thing would be to sort that array and have that sort. First, the number is sorted. Once that number is sorted, now we are gonna what was the second step that has been told? The second step would be to initiate the for loop and do inside the for loop. So before going inside the for loop, we need to declare three variables, right? So 3 pointers basically. So the 3 pointers, for simplicity's sake, let's say 3 values, typical values I, j, and k. So we'll also first let's start for I in range of length of nums. We are gonna go inside. While we go inside, what we are gonna do? We are going inside that. We have the first element. I is gonna be the first element. Then we need to declare what is j. As we said earlier, j is going to be just a one value that is going to be addition to j is equal to I plus 1. Other one is going to be k. K is always going to be length of nums minus 1. Again, if you've been in Python, the loop, when you run through a loop, it starts from 0. And while we calculate the length, it directly counts 1, 2, 3, 4, and 5. So when we are gonna run, k is gonna be counted, right? So we are gonna run through a loop as well. So it starts from 0. So we're decrementing this by 1, so that Python doesn't throw us an error. So these three values are done. Then what we're gonna initiate is we need to initiate that like a two case. I mean, to some problem. While j is less than k, j is always going to be less than k. What we're going to do, we're gonna perform we have to check the addition first. So what we're going to do is final value, let's call it as value is equal to nums of I plus nums of j plus nums of k. We are seeing that value. Once we have added the value, we are going to check if that value is going to be 0 if value equal to 0. In let's run for the pseudocode. If value, so second step, the first pointer is pointing at first element, second pointer is I plus 1, the third pointer is the maximum value. Have we implemented that? Yes, we have. After that, when you add it and you see if sums equal to 0, then we have to increment the second pointer by 1 and the third pointer by -1. So what you're going to do, j uh, first, if the value is met, we have to store it in a set. So so first, then we need to declare a set. So let's say, call our set as store, and this is how you declare a set in Python. So if the value is met, then we need to store the value. We have to store the value in the set. So we are adding this set of values inside the store. Nums of j, nums of k. We are gonna store it in. We are gonna increment the value of j by 1 and decrement the value of j by 1 as well. So this is one condition. What is the second condition, Sita? Else if value is less than 0. If the value is less than 0, then what we are supposed to do? We are just, let's look at the pseudocode again. If the value is less than 0, we are just supposed to increment the second pointer by 1. So j plus equal to 1. Elif value greater than 0. Then we are going to just decrement value, the extreme value, by 1. So once you add it, and it will go through the full loop again and again, it will go for different values of I. Once the for loop fully completed, our store, which is a set, will contain all the unique numbers. So these numbers, if you directly return, the Leetcode expected is that the output is going to be a list. Again, we throw one error. So once all the operation is done and we have a set that has all the unique triplets combination, will return the set, which is a store. But instead of plainly returning them, we'll just convert them into a list and we'll send it. So here, yeah, this is pretty much it, I guess. Suppose we might face some value. Let's see, we might get some error. Let's see how it goes. I don't know why it takes so much of time. So it's gonna give us a runtime error, runtime error. So did that take exactly one argument? Okay, so this is what I was doing. So here, if you see, we are trying to add 3 values at the same time to the store, just because we want these 3 values to be stored together. But if you see the output again, if you see the project description, so it's going to be the form of a form like this: -1, -1, 2. This is one triplet. This is first element of the set. This is going to be second element of the set. So it's a matter of brackets. It should be a bracket inside a bracket. So here, to solve this issue, what we are supposed to do is we want to put one more bracket. So this will be considered as first element of the set, all 3 numbers together. Let's run it again. So yeah, all this is solved. Let's submit it. Yeah, so it has solved. Memory wise, it's okay, good, but runtime wise, it's low. So okay, what we can do? No, I was thinking, is there any way to optimize this? So how we can optimize this? Let's check. Okay, let's go to length on JK. Okay. So what I feel is, let's say we are sorting that array. Let's go to the whiteboard again. Let's say we are sorting an array, and after sorted, let's take a same example. Let's say -4, -1, -1, 0, 1, 2. We have sorted this array now. But after sorting, like let's say what if we get an example where it is just a set of positive numbers 0, 1, 2, and 3. We are given an array like this. In such case, whatever pointer, how much of a pointer you declare, it is never going to be 0, because it's always going to be positive values, and when you add two positive values, it can never get to 0 unless there is an opposite force, which is a negative value. Similarly, let's say we have all negative numbers. Even in this case, how many pointers you use, even how much ever you try to add, if the value is going to be negative, then the values will never going to be 0. Here also the value is never going to be 0. So the one smart way is to reduce the number of time the code goes through the loop, because let's say we are given an array. Let's make sure after sorting, let's say we get an array like this. Let's make sure that the first array is negative. If there is a negative, then there is a chance that it can be added to something and can lead to 0. If it is not negative, directly return an empty list. Similarly, we can check the last element of the array, which is the highest value. If the highest value is again negative, then there is no chance whatsoever that we will be able to find the 3 values adding to which will give us 0. Again, in such case, again we are going to give a empty list. So this should solve a specific problem of running through the loop again and again when you get an integer, when you get an array that is filled with full positive values or full negative values. So we can make this also a part of our code. So what we can do before running through the for loop itself, let's say if nums of 0 is greater than 0, or nums of length of nums -1, which is basically the last element, is less than 0. In both these scenarios, will just return an empty string. In such way, this entire loop will not get executed when you get an array like that. Apart from that, again, we are using a lot of length here and there, so we can say n as the number length. So length of sums. So we'll just put n here, n here, n here. Yeah, I hope this works. Let's see if there is any improvement. What's the problem? Sums is not defined. Okay, it's nums. Length of nums. Yeah. Yes. Okay. The memory has increased, I guess. No. Yeah. It has increased a bit. It beats 11%. Yeah. So this is a solution from my end for solving this 3-sum problem using 2-pointer. Technically 3-pointer, but this is a classic 2-pointer design pattern to solve these data structures. Another way to solve this problem is using hash map. But right now we are trying to focus on solving this problem using a 2-pointer technique. So that's it from my end. If you have any problems or if you have any doubts regarding this code, or if you need any more explanation, please let me know in the comment section. We'll always be available and we'll try to make this problem as easy as possible to you. Thank you. See you again.